Hello everyone, welcome to MK Maths. I am Karthik Mansali. In last video we have explained about 5 marks question one problem. So if you not watched those 5 marks question problem, so please check my description. I have mentioned the link there, so you can watch my previous 5 marks questions solving methods there. So same methods we are applying for this problem also, and this problem is also important. So there are 4 problems. In 2 problems I have explained in previous video, and this is the third problem I am explaining now. So same, now we have to check for 1 and on 2. So there will be a different domain and different codomain and different functions. Okay, so in this question the given a is here the a is equals to real numbers minus 3. So they have created a set A. So in that set A there are real numbers, every real numbers is there, but except 3 they have removed. So why they have removed? So in next we can see why they have removed. Okay, so and they have given B. So B equals to real numbers minus 1. They have removed 1 here. So there is a particular reason why they have removed in domain 3 and why they have removed 1 in a codomain. So while solving, let us understand this also, why they have removed 3 and 1. Okay, so consider the function. They have given a function here. F is a function from A to B. Here A is a domain and here B is a codomain. Okay, defined by the function defined like this. F of x equals to x minus 2 divided by x minus 3. F of x equals to x minus 2 divided by x minus 3. The function is in rational function. So numerator also polynomial function, denominator also polynomial function. So we call this function is nothing but a rational function, rational type function. Okay, in first B you have studied this rational functions. So if is they are asking now is f is 1 and on to question mark, means they are asking for us the given function is 1 or not 1, the given function is onto or not onto, they are asking for us now. So now we have to verify the given function is 1 or not, the given function is onto or not. So we have to use the same concept here. But before start solving, let us understand why they have removed 3 here from the domain. So if you observe clearly, a rational function f of x equals to x minus 2 divided by x minus 3 is there. So if you substitute 3 in the place of x, if you, for example, if 3 is not removed here in domain, then if you substitute 3 here, it becomes 3 minus 2 divided by, in the place of x I am substituting a 3 here. So now the function becomes 3 minus 2 divided by 3 minus 3. So it becomes 3 minus 2 means 1 divided by 0, which is not defined. Okay, so we can't define a function when the denominator is 0. So we already know that when the denominator 0 becomes, we can't define the function. If we want to define the function, then we should not substitute 3 in the place of x, because the denominator here is x minus 3. If you substitute 3 here, then it becomes 3 minus 3 is 0. So our main intention is we should not put 3 here. So if should not put 3 here means, first of all, there should be no 3 which is present in domain. So for the sake of to define the function, for the sake to give a clarity about the function, they have removed 3 here from the real number. They have removed 3. Other than 3, if you substitute any real number in the place of x, there will be no problem. So when you substitute the 3, it becomes not defined. So to remove that problem, to remove that 3, so they have already mentioned, so in domain A every real number is there but except 3. Okay, so and similarly codomain also they have removed 1. While solving on to, we are going to understand why they have removed 1. Okay. Okay, let's start the solution. I hope you understood this domain part, why they have removed 3. Next, while solving on to, when we focus on codomain, no, then we are going to understand why they have removed 1 here. Okay, so from solution, let's start the solution. The solution is 1 okay, 1 we have to check the solution now, it is 1 or not. Okay, Same, first same line. Let us consider, if you watched my previous two questions, then you are going to understand. I have writing same sentences. I am using same concept for each and every problem. Just domain and function values are changing here. That's it. The same the sentences structure will all same for three problems also. If you observe my three problems, the structure and writing method is same. To show one, I am using the same structure here. Okay, I am following same structure, so it is easy to remember and it is easy to understand. So for that sake, so let us consider. So I have to consider two elements x1 and x2. So x1 comma x2, which is belongs to domain. Here domain is a, so I am mentioning as a itself, not r here. We have to mention a. So whatever the domain they have given, we have to mention that symbol only. If they have given z, we have to mention z. If they have given n, we have to mention n. If they have given a, we have to mention a. Okay, for in a, what is the set? We have to remember, in a contains real numbers except 3. Okay, all real numbers is there, but except 3. I already told why they removed 3. Okay, so let us consider x1 comma x2 belongs to R. Next, so for this x1 there will be image in codomain f of x1. For this x2 there will be image in codomain B f of x2. For two elements in domain, there will be two images in codomain, because it is a definition. It is a definition of a function. Next, these two images, I am going to assume. So I am writing it as suppose means if it happens means what will be the outcome, so that we have to check. So what if it happens means here I am using the word suppose f of x1 and f of x2, two images are there, no? So when suppose if these two images become equal, then what will happen, we have to check now. So suppose f of x1 equals to f of x2, then the function will become, so here we have to check the question. So the in question they have given f of x as x minus 2 divided by x minus 3. So for f of x1 means x minus 2 divided by x1 minus 2 divided by x1 minus 3. In the place of x we have to substitute x1 here. Okay, so next f of x2 means x2 minus 2 divided by x2 minus 3. So in the place of x there is x1, so the function will become x1 minus 2 divided by x1 minus 3 equals to x2 minus 2 divided by x2 minus 3. Okay, so now I am going to solve here. So just cross multiply here. So numerator should, I have to remove the numerator part, then only we can calculate easily. So I will cross multiply each other side. Here x1 minus 2 into this denominator x2 minus 3. So x1 minus 2 into x2 minus 3 equals to, now this I cross multiply here, x1 minus 3 into x2 minus 2, x1 minus 3 into x2 minus 2, x1 minus 3 into x. So this x1 minus 2 into x2 minus 3 I have cross multiplied equals to x1 minus 3 into x2 minus 2. Now there will be a no denominator here, everything will be on numerator, so then it will be easy to multiply now. Okay, so let's multiply now. So this x1 is multiplied to x2, then it will become x1 into x2. Okay, this x1 is multiplied to this minus 3, now it becomes minus 3x1. So I am multiplying all this x1 I am multiplying this x1 with minus 3, then it becomes minus 3x1. So now this x1 part is complete. Now I consider this minus 2 into x2. So now it becomes minus 2 into x2 as it is I am writing here. And next minus 2 into minus 3, minus into minus plus, it becomes 2 into 3, now it becomes 6 equals to, I hope you understood the left side part how I calculated. In same way I have to calculate in right part. So observe here. So x1 same, x1 is multiplied to x2, so I am writing it as x1 into x2. So if this x1 is multiplied to minus 2 means minus 2x1, this x1 is multiplied to minus 2 means minus 2x1, and next this minus 3 multiplied to x2 means minus 3x2. This minus 3 multiplied to minus 2 means minus into minus plus 3 into 2 6. Okay, left side part is completed, right side part is completed, brackets are all removed, and I have multiplied each and every element. So now I have to calculate which are similar here from left side, right side, which are similar. We have to cancel. Here I am going to cancel out which are similar. So here x1 x2 is their left side, right side part also we are having x1 x2. Here 6 is there, plus 6 left side, and right side also plus 6 is there. So I am going to cancel out here, because if you move this 6 to right side means it becomes 6 minus 6 0, no. So before only I am cancelling here, left side right side which are same we are going to cancel here. So if you observe here we having minus 3x1, and we are here we having minus 2x1. So it both are different, so it is not possible to cancel. Here we are having minus 2x2 and minus 3x2, so both are different. Coefficients of x2 are different here, so we can't cancel here. So we only can cancel x1 into x2, here x1 into x2, here left side 6, right side 6 get cancelled. So the remaining part will be, we have to find x1 equals to x2 or x1 not equals to x2, no. So I am transferring x1 all one side, x2 all one side here. So I have here x1, so I am writing here minus 3x1, and again I am searching for x1. Here right side I having a minus 2x1, so I transfer this minus 2x1 to left side, it becomes plus 2x1. Okay, minus 2x1 is there, no. So I transfer this minus 2x1 left side, then it becomes a plus 2x1 equals to, now right side I maintain x2 terms. So right side already we have a x2 term is a minus 3x2. Okay, minus 3x2 already is there. So when it comes to left side, here we are having a minus 2x2. Minus 2x2 moved to right side means it becomes plus now, plus 2x2. So if you observe, x1 all become one side, x2 all become one side. After solving this, minus 3x1 plus 2x1 means minus 3 plus 2 means we get a minus x1. Minus 3x2 plus 2x2 means we get a minus x2. Here minus minus get cancelled, so it becomes x1 equals to x2. Now it becomes x1 equals to x2. Now easily we can write, here we can write, therefore f is 1 function. F is 1 function because we got x1 equals to x2. We got x1 equals to x2 here. That is our aim. So I hope you understood this calculation part. Just I have cross multiplied here and multiplied each element with other each elements, and I cancel out which are similar, and I separated the x1 terms are one side and x2 terms are one side, and after cancellation we got x1 equals to x2. Then the given function is 1 1. So 1 1 it's satisfied. Now I have to check for onto. So next we are going to check for onto concept here. So same sentence we have to write. So let us consider y belongs to codomain. So let's check here. Codomain here is, see here, if you observe here we are having a codomain B. Domain A already we have used, so when it comes to onto we have to use the codomain. Codomain is denoted as B here, so I am using B here. So y belongs to B, which is nothing but codomain. From codomain we have considered one element. After solving we have to move to domain, so that element we name it as x here. Okay, next after considering element in a codomain we have to make sure that is equal to f of x. F of x is nothing but image of x which is present in codomain. Both are same now. So now it becomes y equals to f of x means we having x minus 2 divided by x minus 3. So here f of x having x minus 2 divided by x minus 3. So now y becomes x minus 2 divided by x minus 3. Our main intention is to find x value. Okay, y value we are already having. So we have to move from y value, using y value we have to find the x value. If that x value present in domain means onto. If it is not present in domain means not onto. Okay, so our main intention now is to find x value. To find x value, again this denominator part I'm cross multiplying to left side y part. So if x minus 3 into y, so if I cross multiply it becomes y into x minus 3 equals to x minus 2. So First we have to remove the denominator parts, then only it will be easy to calculate. Okay, so now y into x minus 3 equals to x minus 2. So if you multiply this y to x, it becomes yx. This y to minus 3, we have to multiply this y for both x and minus 3. Okay, if you multiply this y for x, it becomes yx. If you multiply this y for minus 3, means it becomes minus 3y equals to x minus 2. Now our intention is to find x value. It means we have to make separate x values one side and the remaining all one side. So x already present, so I am not going to change this. Yx I am writing it as same as it is, yx, and finding for a x term which is present in a right side here, x. So if you transfer this x to left side, it becomes minus x equals to, so if you transfer this minus 3y extra minus 3y to right side, it becomes plus 3y minus 2 as it is, minus 2 as it. I have transferred this x value left side and I have transferred this minus 3 value right side. That's it. So yx as it is. If I transfer this x value to left side, means minus x equals to, if I transfer this minus 3y to right side, means it becomes 3y minus 2. So now I have to take common between these two terms is x. So x term is the common here. If I take common x, the remaining part will be y here, minus if I take common x here, the remaining part will be 1. So if I take x as a common, then the remaining will be y minus 1, which I have written in bracket. So equals to 3y minus 2. So now we got x into y minus 1 equals to 3y minus 2. Now our intention is to find x value, no? So x I keep as it is. So here for x, y minus 1 is multiplying. So for the x, y minus 1 is multiplying. If you remove this multiplied y minus 1 to right side, it becomes division. Y minus 1 here is multiplied. So if we move this to right side, it becomes a division part. So 3y minus 2 as it is divided by y minus 1. So now we got x value as 3y minus 2 divided by y minus 1. If you observe clearly here, if you substitute 1 in the place of y, if you substitute 1, it becomes 0, denominator becomes 0, then the x will be not defined. So it is not possible here. So we have to make sure we should not put y value as a 1, because if you put y value, then the denominator will become 0, then it will be not defined, then it is not possible to check onto. So to check onto means first the function should be defined. So it should be defined means we should not put y value as a 1. So for that sake, we have considered y from b, no? So for that sake, in b they have removed this one. I hope now you all understand this. Hope you all understood this now. This minus 1 they have removed. No, why they have removed means, if there is a 1 in a codomain, if you substitute that 1 in the place of y, then it becomes not defined. So to be defined, to define an onto function, so we should not keep 1 in the place of y. So they have removed. So there will be no problem now, because in b there is real numbers which except 1. There is no 1 present in b, so there will be no problem. Here we can substitute any y value other than 1. Okay, so if you observe here x value clearly, we got 3y minus 2 divided by y minus 1, which is nothing but a fraction, so we know the fractions will be in real numbers. Fractions are present in real numbers, 1 by 2, 3 by 2, 5 by 6, 7 by 2, 9 by 8. All those fractions are which are present in a real numbers, and that too, this fraction part is defined because we are not substituting 1 here. They have removed from the codomain. Why we are bringing from codomain? No, in that codomain there is no 1 value to put here, and to create a not defined, there is no y value here. So for this example, if we take y value from this codomain b, then it is a perfectly defined. If it is perfectly defined, it becomes a fraction. It looks like a fraction. Fractions will always be in real number. So then we can conclude, then this x is belongs to a. A is domain, no? So this x belongs to a, which is domain. So I have considered the y in codomain and I have found the x which is in domain. Then easily we can say it is onto. Before saying onto, we have to write this sentence. So the sentence is nothing but, remember this sentence because this is very important. For all y belongs to b. So same here, what we have considered for each y, no, we have to mention for all y it will satisfy. We have to conclude for all y it will satisfy, then we can say f is onto. So here we have considered only one y, no, so this concept will apply for any y. We have to mention that sentence. So for that sake we are writing here, for all y belongs to b. This for all y belongs, any y you took, any y you take from the codomain b, there exists x here. There exists x. There exists x equals to, x is nothing but here same what we have got, 3y minus 2 divided by y minus 1, which is belongs to a, which is present in a. So for all element which are in codomain, there exists a element which are in domain. We are writing general sentence here. For all y belongs to b, there exists x. There exists x. 3y minus 2 divided by y minus 2, y minus 1 belongs to a, such that, how it exists means such that if you substitute in the place of x, such that f of x equals to y, no, in the place of x if you substitute this 3y minus 2 divided by y minus 1, you are going to get a y value. So such type of a x we are getting. If you substitute that x value, we are going to reach the image in codomain y. Okay, I hope you understood this sentence. After writing this sentence, we can conclude here f is onto. Here f is onto. Here f is onto function. I hope you all got this. So here we have considered the element y belongs to b, and we know that y equals to f of x. After solving this, y equals to x minus 2 divided by x minus 3 cross multiplied. After some simple calculation, we have removed the x as one side and remaining part as one side. This x which is belongs to domain, because this is a fraction part, that to defined fraction part which is always belongs to real number. So real number, a contain real number, so it belongs to a, and we have written for all y. This concept will happen for all y, and there exists for all y there will be an x, 3y minus 2 divided by y minus 1, such that how it will be means f of 3y minus 2 divided by y minus 1 equals to y. It means, see here, so here y we have considered, no, so in codomain we have considered y, this is b, no, so this is a, this is a. To move from y to here, we got x value as a 3y minus 2 divided by y minus 1. If you substitute this y value here, we will directly reach to x point, which is belongs to domain, that type of x we got. So to reach domain, so then it is a onto function. Okay, I hope you understood this one and onto for this problem. So if you have any doubt in these three problems in previous two videos, or this problem, please comment in comment section so that I can know which part you are facing a doubt, and I am going to clarify in comment section, or I am going to clarify in the next video. Okay, up to then, tata, bye bye.